Okay? Okay, let's come back to do some actual use of what we just told you. Okay? So, suppose this is the retailer's problem. This person has a first decision to make. Either he can hold a small stocks or hold large stocks of stocks of good. Okay, and if he holds a small stocks, then if the sales is low, this person will earn this much. If the sales is high, then he will earn more. And so low sell 80 and high sell is 140. But if it is if you hold a large stocks and the sales is low, then a lot of the stocks go into waste, right? At least you have many stocking cost. So the profit is much lower. The profit is only 20. But if you have a large stocks and the sale is high, that means you can sell a lot of things out. You can sell even more stuff out. So the profit is even higher. So it's 220. Okay? And so the decision is between small stocks and large stocks. And you should already know how to do this, right? So I convert the profit into utility by a utility function we taught before. And then this number times the utility, this number times the utility, this number times the utility here. And you will get a expected utility as shown. And then you choose the one with higher expected utility, which is hold small stocks. Okay? This is what we already know. Suppose there are new information come in. This information basically is a forecast of future sale. Before you make this decision, before you make the stocking decision, you can observe some forecast. This forecast has reliability as follows. So if it is a low sell, then 20% chance it will tell you it's a high sell. If it is a high sell, it has a 75% chance it tells you it's a high sell. So if you see a forecast of high sell, you will do the Bayes theorem and then arrive at this posterior probability. So if you see a high sell report, you will adjust the belief to be 50%, 15%, and 85% accordingly. So basically, you use this new probability as the new probability to include into your decision problem. Again, the probability times the utility, and you get the expected utility. Now you find that actually holding a large stocks has a higher expected utility. So this new information changed your decision, right? So far, all good? Okay. No? Yes.
How did you get the utility? Like just with the...
This part?
No.
So we talked about this last week. So you have a utility function. Here we don't actually see the function, but you assume back there's some function. Okay, and then it can convert the... So utility functions are like this. For example, this function tells you that u of 80k is 0.5, u of 20k is 0, u of 220k is 1. So
arbitrarily decided.
It's not arbitrarily decided by you, by decision maker. So in the exam, for example, you will either have a utility function, or I will ask you, like in the exam, you find a utility function. Okay. So how do you actually? So more kind of content in utility function, you should go to a microeconomic course. That's why I'm not what I'm teaching here. That's why I skip most of the stuff. That's why it seems arbitrary, but it's not really arbitrary. It has a lot of the. So for example, it has to be. So if you assume someone is risk neutral, it must be a straight line. So it's not arbitrary. Okay. So for example, here, if 220 is here, and the 20k is here, and 80 is at the middle. 80 is around here. So it's probably like a utility function like this, approximately. I just short to let you get a brief idea. That's all. Okay. I think the textbook actually give you the utility function, right? Yeah. So I skipped that part because it's not really important for this part. And you know how do we get the expected utility, right? Right?
It's from the low cast times utility and then the high sales times utility, right?
So 0.115 times this plus 0.85 times this equals this. That's the definition of expected utility. Okay? We told you what it seems like you guys know what is expected value, right? Expected utility is the same thing, but you just replace the value with utility. That's all. Okay? Okay. So this one is easy. You just whenever new information come in, just replace. But now we want to ask a slightly different question. This is kind of an interesting exercise. So we want to determine the expected value of a perfect information, or EVPI. Okay, so we go to a slightly different question. So in this question, so the title here is all wrong. It's not the retailer problem anymore. Okay, so I forgot to change the slide title. So now you are a potato planner. Okay, so you decide your choice either to plant a potato or plant something else, a alternative crop, or you seek perfect information. Okay, so if you seek for a perfect information, this information is gonna tell you. Sorry, I forgot to say. The reason why you're gonna be hesitant about whether you're gonna plant a potato or plant something else is because the potato is affected by some kind of virus. Okay, so if under the ground there are virus, then if you plant the potato, then you will actually lose money. And if no virus, the virus is absent, then you will earn a lot of money. Okay? So here, for example, the expected return is this much. And if you plant for alternative crop, then you will get 30K for sure. And if you seek for a perfect information, the perfect information, because the information is perfect, so if there are virus, it will tell you there are virus. If the virus is absent, it will tell you it is absent. And before you take this test, you already know 70% chance you will get a result saying there is virus. 30% chance you know there is no virus, right? Sorry, the opposite. 70% absent, 30% present. Okay, so in this case, after you get this perfect information, 70% chance you will go to this route. 30% chance you will go through this route. This is not probability tree anymore. Okay, this part is not probability tree because well, it's also probability, but it's not like here. It's different because this is a after you plant your potato, then you can see whether there is virus or not, and you only see the result when you lose money or you only see the result when you see whether your potato all go to waste or the potato actually grow very good, right? But here, this is like after before you take the test, you know there's two sort of a storyline that you can go. One storyline, you will find that there's virus. One storyline tells you that you don't have the virus. Is that clear? Okay, so the reason why this is 70 and 30 is because this is a perfect test. So I know for sure it's gonna be these two probability. Okay? And if the virus is absent, then here the decision, well, you can still plant potato or plant something else, but here you don't need to do that decision. It's clear that you should plant the potato because the virus is not there. In that case, you will earn 90K for sure, because in this case, in this timeline or storyline, virus is absent for sure. This now is a 100% chance. Okay? And here, with 30% chance, you will see the report tell you that there is virus. Okay? And then you will simply plant something else. You'll plant flower maybe. And then you'll get 30K for sure. Okay? So this is the whole story. So now consider this. So I was just saying whether you want to seek for this perfect information. Okay? But in the real world, information don't come in as a free lunch. You need to, a lot of time, you need to buy the information. Even if the information is free online, you need to search for the information. Maybe because this information is hidden in the dark web or something, you need to really go through a lot of trouble to get it. So there's some cost always to get the information. The question here is, how much are you willing to buy this information, to buy this information? How much at most? If $1, you definitely would pay for it, right? $2, you also pay for it. But how much at most you will pay for it? The calculation here is actually quite simple. You already know that the expected return here is 57K. This is getting from, these two and add it up together. And between these two lines, you will definitely choose this one. So from here, you know that if you don't seek for the information, If you don't seek for the information, you will get 57K for sure. Not for sure, but on average, you will get 57K. Okay? And what if you seek for the perfect information? If you seek for the perfect information, okay, so I guess I just realized there's a better way to draw this graph, okay? So I think it could be the first decision is you seek, not seek perfect information, or you seek perfect information. And if you do not seek perfect information, you go to the original graph. The original graph is referred to this part. Okay? And if you seek for the perfect information, then you go to this part. Okay, so there's a prior decision you make whether you want to seek or not seek the information. Okay. The textbook is just simplify. The textbook simply simplify the graph. Okay, I just add one stage. That's all. Okay? I think it's clear that way. But anyway, so if you seek for the information, you can also calculate the expected payoff, right? If you seek for information now, if you get the positive, the saying that the virus is absent, then you will get 90K for sure. If you see there is virus, you'll get 30K for sure. Again, this times this together gives you an expected return of 72K. So if you seek further information, the expected revenue or return is 72. If you don't seek it, the expected revenue is 57, right? So the difference between them, which is 15K, that's how much you are willing to pay at most to buy this information. Because as long as you pay, the money you pay to buy this information is less than this money, you are willing to do so because your expected return is still higher.
If you have a chance of losing everything, but if you seek for information, you don't have a chance anymore of losing.
That's already considered in the expected returns calculation. That's why if you seek for the information, the expected return is higher.
Yeah, I know, but and it's not continuous, it's discrete. So here in this case, it's our discrete result, and the AVP is continuous.
It's the same thing. Yeah, it's the same thing. And if it is continuous, you can't really do it by your hand. You need to, or at least not by simple math. You need calculus to help you. So I won't test you that for sure. Yeah. Are we clear about this? This is really important for today. If you don't know how do you get the 15K, you should raise your hand now. Let me know. We good? Okay. Oh. Okay, so actually the textbook also already did what I said. So you separate the first stage into do not buy the test or buy the test. Okay, and then this part is exactly the same. And after you buy the test, before I say that the test is a perfect test, Right now, I consider imperfect information. Imperfect information means, like I said before, the reliability of the test is not 1. It's not 100%. Okay? So now suppose it's not reliable, not 100% reliable. So what is the probability that the test will indicate virus? Okay. And what is the probability that after you plant the potato, the virus is actually present? That's the answer. You need to fill in this question mark. That's the whole difficulty here. All the difficulties here. Okay. So to this part, so I know the prior is 70 and 30 and 70, right? And the new information, suppose that the reliability is shown as follows: 90% here and 20% here. This case is not symmetric. Okay, it doesn't have to be symmetric. Okay, in this case, it means that if the virus is absent, the test will tell you 90% chance that the virus is absent. But if the virus is present, the test will tell you 90% chance that the virus is present. But if the virus is absent, it will still have a 20% chance to tell you that the virus is there. Yes, question?
And how to define the reliability of the test? Like
You don't find it, you have it. That's the given information. Where in the text, yeah. Or during the exam, that's gonna be in the question. Yeah. That's like the coronavirus example. I tell you that the test is gonna be 40% correct, 60% incorrect, right? That's exactly that thing. Okay. So based on this prior, I can arrive at the posterior. It's actually just 2/3 and 1/3. Around that number, yeah. Okay, so basically, you will replace test indicate present test. So if test indicate present, okay. So sorry, I was wrong. I'm not answering this part. I'm actually answering this part. So if the test tell you that there is virus present, I'm actually believe that 2/3 of the chance it actually 2/3 of the chance the virus is actually there, and 1/3 of the chance is actually absent. Right? Similarly, you can do the exercise for virus if the test indicate virus. Oh, it's typo again. So this should be absent, I guess. Or no, this should be absent. Okay. And if the test indicate the virus is absent, there's also the probability is either the virus is actually there, the test indicate no, or the virus is not there and the test also indicate no. So you also do the Bayes theorem and arrive at the posterior to be 95 and 0.5. So this one gives you 95 and 0.05. And this number, 41, what does it mean? It means the probability of the test indicate that virus is present, right? And that's exactly what we need here. And this one is just 1 minus that. So this is what you get after you insert 0.41, 0.59, 0.66, 0.34, 0.05, 0.95. And now you can use the, remind me, is it called rollback or some other name or some back? Basically, you calculated the expected revenue or earning for this, you get this. So this one gives you this, these four numbers give you this. And then you here is a decision, so you either choose to do this or do this. And so because 84 is 84.5 is higher than 30, so you will choose to go this line. Here, between these two, 30 is higher. I will choose to plan alternative, so I will get 30 in that case. The expected number I get will be 30. And here, you will get 84.5 and 30, and the probability here, these four numbers give you the expected earning here. That's gonna be 62 and 62,155. So that's after you buy the test, which is not a perfect test. You know, it's a not perfect test. Then you will be willing to, the expected earning is 62 something. And remember, if I don't buy the test, I will get 57. So 62 is still higher than 57. So 62, this number minus this. So I will willing to pay around 5,000 to buy this information, even though this information is not perfect. This is how much you will pay for, basically this is also called the expected value of the imperfect information. A little bit more difficult than the perfect one, but the idea is actually the same. A little exercise that you can do is that you can try to do the exercise for imperfect information, but assuming that all the probability are 1 or 0, means all the information are perfect, then you will see why the imperfect can be degenerate into a perfect case. Okay? So that's an exercise that you should try, because it gives you a clearer idea of how you arrive at this number. Okay? The textbook will also tell you another way to get this number, but that one is the basic idea is the following. So forget about it. I think it's just gonna confuse you guys. So you just need to learn these two methods. How do you get the perfect and imperfect information, the expected value of the perfect and imperfect information? So yes.
Is that 5,166 or 55?
Sorry, what?
Because in the textbook they find 1,166.
I think you're looking at the second method.
Yeah.
Yeah, so the second method and the first method, the two methods actually should give you exactly the same number, except that because there's some rounding error, so rounding issue, so it give you not exactly the same number, but it's close to each other enough. Yeah. The second method actually can tell you the answer of this number 5,000 something a little bit quicker. But that method requires a lot of this logic thinking process and assuming a lot of the hypothetical situation, that kind of mindset. So I don't recommend you to go through that before you really understand what I'm doing here. Okay? Okay. So I'm not going to be able to finish